So hello everyone, I am Rishi and starting with our new flight controller video, My Flight Zero. So today I will give you insights of My Flight Zero codes. So My Flight Zero, this is basically My Flight main code. So first is My Flight Zero code. So this code is divided into two parts. So the first code gives you information about gives not information, stores the calibrated data in the EEPROM. The second code uses calibrated data to make quadcopter functional. So in the first code, we are calibrating gyro and joysticks. Okay, so for the things you will need for this is MPU6050. The things provided with a double hash are required and mandatory. The things not provided with double hash are not required. If you want, you can. Their support will be further added in my next videos. So this code will be keep update. We will keep it updating in my next video. So I'm using MPU6050 as my basic accelerometer, and they're very popular today. ESC is more mandatory. BLDC motor. This ESC and BLDC motor are your choice. I will also upload a video. You can find many videos on YouTube too about telling you about which ESC you should use for your BLDC motors. Then jumpers are mandatory. Frame is mandatory. Propeller is mandatory. And multi-way GPS I2C, we will add GPS support further. So if you want, you can buy these components now. Otherwise, you can buy it later on. Then we will use PCB board, Arduino Nano, power distribution board, and other things. Okay, so now the basic tools you will require is soldering iron, solder wire, heatsink sleeves, wire cutter, and basic lighters. And then all we will require this. So this is the code is this. So here we are defining the gyro calibration address 0 in our EEPROM and joystick calibration address 10. So first gyro calibration data, it will calculate the GX offset, x-axis, y-axis, and z-axis, as all of us know. Then joystick axis, joystick only has two axes, I think, and then calibrated data. This will calibrate using this serial. So if you will command J, it will calibrate both joystick and calibrate gyro. If you command C, it will calibrate joystick. If command L, it will calibrate our gyroscope. So if you first put on calibration data, then it will print in the serial, move joystick to its maximum position. You can, and the further functions will be printed. I have ordered this too. So when the parts come, we will go on further. Now joystick calibration data, and you should have an insight with the code so that while updating or debugging, you should also not have any this issues. So now starting arrow calibration. So this arrow calibration complete. Okay, then this all. And yeah, another thing, while gyro calibration, don't move the quadcopter. So that's storing store calibration data EEPROM put. EEPROM.put is used for to store calibration data and serial print. Gyro calibration complete. Then load gyro calibration data. It will this verification stage loading in the EEPROM. Next is My Flight. So this My Flight is the main flight controller. We are using it via GPS, tiny GPS library, MPU6050 library, software serial wrapper, EEPROM. If you don't have this library, just go to Edit, Sketch, Include Library, Manage Library. Wait a minute. Now type here. It wait for updating list of installed libraries. Now type here tiny GPS and press enter. Tiny GPS came above. Okay, click on this. Already installed, so no instruction. There are many, but we are using tiny GPS plus plus. Okay, so remember plus plus we are using. So I have already installed the latest version, which is 0.004. Okay, then search for MPU6050. Press backspace. MPU6050. Searching. Adaptive MPU6050. I already installed the latest version 2.2.05. basic MPU6050 and MPU6050 electronic cats. Okay, now close this. So now MPU6050 tiny GPS software serial. So we will now go through. This is the whole code attached in the description. This is motor 1 pin, motor 2 pin. This is pitch roll and pins of the following. Now this is pitch. So I am using proportional gain, integral gain, derivative gain. All of us know we are using Kalman filter here, EKF, extended Kalman filter. So we are not defining the PID. It will be defined by the Kalman filter. Okay. Set calibrated data, MPU gyro calibration data. It will extract. Okay. Okay. Now, so like this, throttle pulse in and another data. Then motor outputs. It will calculate here in this. It is throttle based on altitude. Altitude hold is from sonar. Okay, so sonar trick pin and echo pin, here it is defined in the code. You can find it. Okay, then float after Kelvin filter reads sonar data. So here motor motor 1, motor 2 and motor 3, it's already there. Okay, motor outputs using PID control for pitch roll. So you can use PID control. You can adjust PID according to your model, and then adjust throttle based on this, ensure within limits. Read GPS data here, GPS data. So print sonar data. So I have used print function because so that we can get the offsets of what is being done to our quadcopter. What are the things happening? It will be printed. I have used basic board, which is 9600 baud. You can access a serial monitor from here, but I have not attached any board, so it will not come. So here, and the PID is more important. So we go through PID and this. So yes, read sonar data, and I have. So we will find here sonar. I have attached previous. So print sonar distance previous. We will go to previous sonar trick pin, sonar echo pin. Yeah, here I have defined. So sonar trick pin is 7, sonar echo pin is 8. Okay, and receiver pins are also here. So you have to just find it. A1, A2 and A3. A4 and A5 are STL STA pins of Arduino Nano. So don't use them in your codes. Okay, make sure all the things are defined. Okay, so Kalman filter, all of us knows. Most of you might be not knowing. You can go through. There are multiple videos on YouTube, so you can print sonar distance. Okay, the things, and also one more thing. Here, if you go to by HMC file, this is a magnetometer, accelerometer, and this BMP 180 is our barometer. So this HMC 583L, what's the problem with this? You will also get many products from the market naming as QMC 583L, but HMC 583L is the real one, original one, manufactured by Honeywell, and it's not more fairly available in the market now. So you will mostly find QMC 583L. The problem with both of these are QMC 583L is a different I2C address and HMC 583L has a different I2C address. So I will develop for my code for HMC 583L, not for QMC. So go with HMC and then multi-V GPS I2C. So I2C. So we will require this because Arduino Nano, as you know, only has one TX RX pin which it shares with its our USB port. So how we will get the and we will need two Arduino Nanos because in flight we want to access our serial for this terminal option and everything. So how we will access it? We cannot make a USB attached to it and go long till that way. So we will use HC12, not attached here. I will also add it HC12. So this is a RF module used to send Arduinos. Okay, so serials over here. It has a 1 kilometer range. So what you have to do is you have to take a Arduino Nano and attach its TX-RX. If you search here HC12 Arduino connections, you go to images, you will see here. So this is HC12. just add the TX to the Arduino RX and the Arduino RX to TX, 5 volt to 5 volt, ground to ground. Yeah, you will also, if you are using U by ESC, you will need a back. If you are using S by ESCs, you will no need a back. Okay, and when you take ESCs, just make sure that they are 5 to 4 to 5 amps more than your motor max amp for better efficiency. Here I will be using 2300 kV PLDC motors, but if you want you can go with uh, if you want you can go with 1400 kV BLDC motors. So if you go with 1300, take a propeller of size around this 8 inch, but here I am using, so I will take a 5 inch. My frame is Mark 4 6 inch, Mark 4 6 inch, and my jumpers are necessary, as you know, for these projects, and the PCB board you will need. Okay, you can also use a breadboard if you have. ESC minus Cyclone BL Helios firmware. Okay, so in next video we will attach another uh, we will attach another code for calibrating all the four ESCs using just together. Okay, so we will attach another code in our this code given base code. This whole code is base code and will be upgraded in my further videos. So be awaited. If you like, give a like and subscribe also, and if you want, press the bell icon so get latest updates. So this whole was my code attached in the description. You can see it. Okay, so what my vision is to make a quadcopter fully autonomous. So I will using Python elementary. You may be not familiar with it, but you can search. But Pi is now very much famous nowadays, and also a very favorite item of engineering enthusiasts. So basically, I will be using that. Okay, so gyro calibration, joystick, and void. This is calibration data and my flight 0. So if you are already having the components and trying to test out this code, first apply my flight 0 and then my flight. Soon this is open source. Okay, so you are free to share all your things with me in comments. If you want if you have any ideas about this, you can put. I will surely implement those ideas. Okay, so I am attaching this folder in our description. Thank you for watching. Yeah, bye.